I recently tried to build the ultimate chat server. My goal was simple, pure speed, no database, no history, just a raw high performance TCP relay using Rust and Tokio. I thought I had the perfect stack. I thought I understood async programming. But when I actually stress tested the architecture, I realized I hadn't built a high speed server. I had built a memory leaking, single threaded bottleneck that would crash the moment it hit the production. In this video, I am going to show you exactly how I messed up and the three line of code that destroyed my performance and the new switchboard architecture I designed to fix it. First, let's look at the prototype, and the idea seemed logical. I used Rust for safety and Tokio for async networking. The logic was simple. When a client is requesting to connect to the server is accepting the TCP connection and is spawning a new Tokio task for each client. And it compiles, it runs, it handles a few users perfectly. But hidden in these 10 lines of code are three messy problems. Let's do a code review. The memory bomb. I used unbounded channel. In my head, this meant infinite buffer. In reality, this means infinite RAM usage. If I have a fast sender and a user on 2G connection, the server will hold all the data in RAM waiting for the slow user. One spam attack and the server crashes with out of memory. Look at this Arc Mutex sender. Tokyo channels are already thread safe. They are designed to be cloned. By wrapping this in a mutex, I forced every single concurrent user to get in a single file just to send a packet. I took a multi-threaded async runtime and turned it into a single threaded bottleneck. Just check the red line in my concurrent server. As users join, memory usage explodes until the OS kills the process. To solve this problem, I needed to stop thinking in queues and start thinking in maps. So I created a new architecture, the switchboard architecture. So I threw the old code away, and here is the new architecture. Let's take an example. When Analyze connects to the server, there is one separate channel is created for Analyze and server only. And when Bob connects, he has his own channel for communication between server and the Bob. When Alice messages Bob, she looks him up in the map and drops the packet directly into his queue. So here is no global mutex blocking everyone else. If Bob is slow, his queue fills up and Alice is forced to wait. The chat server stays stable, low latency, and crash proof. This shifts from global queue to decentralized actor model is what separates a toy project from production. In the next video, we are going to open up VS Code and implement this from scratch. We will set up the dash map, we will implement the client struct, and we'll fix that memory leak once and for all. If you want to check the code, the previous server code, you can check my GitHub link. I will attach the GitHub link into the description section. If you want to see how to write high concurrency Rust that actually scales, hit subscribe and I'll see you in the next build.